Welcome back. This is the day the Lord has made. Let us rejoice and be glad in it. In this video, I'm going to introduce organic chemistry. So we're going to actually have a three-part video series here over organic chemistry. In this first one, I'm going to talk about just introducing it, the general idea of what organic chemistry is all about, talk about some formulas for different types of organic hydrocarbons. In the second video, I'm going to talk about how to name things and go into detail about that. And in the third video, I'm going to talk about isomers. So in this first video, I just want to introduce the basic organic chemistry stuff for us so we have a general vocabulary to work with here. Anyway, so here we go. So organic chemistry is all about the study of hydrocarbons or just carbon-based compounds. So the general idea is if it has carbon as its root, as its base, as a big molecule, it's an organic compound. All of our bodies, not all of our bodies, the living part of our bodies, so not the water, but the living part, the big molecules, they're basically carbon-based. When God made us, he used carbon because carbon makes a bunch of branches. It can be this huge big molecule and make a bunch of branches. So carbon can make 4 bonds. It's the king of bonding. And so it makes a bunch of bonds and it can grow into these huge molecules, which can make proteins and enzymes, carbohydrates, lipids. They're basically all carbon-based compounds. They're huge molecules. So when we talk about organic chemistry, all we're saying is it's a carbon molecule. The molecule has carbon as its backbone, and there's things attached to it. All right. So there's different types of hydrocarbons. There's alkanes, alkenes, and alkynes. It comes down to whether we have single bonds, double bonds, or triple bonds between the carbons. So for future chemistry classes, you can talk about aromatic stuff. In this class, we're going to ignore it. So for alkanes, alkanes means that there's just single bonds. All right, between all the carbons, there's a bunch of single bonds. An alkene means that there's a double bond present somewhere. And you can have more than one double bond. We'll talk about that later. An alkyne means that you have a triple bond that's present somewhere. So alkane, single bonds between the carbon, alkene, double bond, alkyne, triple bond. So if you're an alkane, and this means you just have single bonds between the carbons, this means that you're saturated because every single carbon has as many hydrogens as possible. So like a saturated fat, all it means is that the carbons have as many hydrogens as possible. That's what it means to be a saturated fat. There's as many hydrogens as possible on the fat. So, and we didn't talk about hybridization in our normal chemistry class, but we did talk about the shape being tetrahedral. So if you think about CH4, it would have a tetrahedral shape, which means it's 3-dimensional. We didn't talk about single bonds, that just means single bonds. Single bonds can rotate. So this allows the molecule, if it's made of single bonds, to kind of flex around and move and rotate. An alkene would be something that has a double bond. This is an unsaturated. So if you are unsaturated, like an unsaturated fat, you could have more hydrogens, but you don't have as many. Unsaturated fats tend to be healthier for us because they actually have this double bond that could be attacked. So you can think about that double bond as being a place that's not saturated, and it's a way for the body to come in with its enzymes, hydrochloric acid, to kind of like scissors it right there and cut it right there at the double bond. So as far as you're concerned, saturated, unsaturated, saturated is as many hydrogens as possible, and solid at room temperature. Unsaturated is liquid at room temperature, could have more hydrogens. So it's important that alkenes have the double bond and alkynes too. What this means is it actually makes it like a flat wall. Like, because it can't rotate, it also makes the molecule trigonal planar. So what that means is we have a flat plane, and it can be really big. So you can have a whole bunch of these where you have a bunch of double bonds, and it makes this molecule a big flat wall. And so when our body uses like alkenes, it's using them usually for structure. So it's like making a wall. Alkynes, they just have a triple bond. These things are also unsaturated. So the difference between an alkene and alkyne is just now the carbons are even more closely connected. They've shared more. So some of the stuff I ask you, can you calculate the formula from alkanes, alkenes, alkynes? And it comes down to knowing how many hydrogens are present. So for an alkane, since every single carbon has as many hydrogens as possible, the formula is for every carbon, there's 2 hydrogens plus 2. That's because the end carbons, the carbon on the very end, they're going to each have 3. Because the carbons on the ends, they have 3 hydrogens, and then the carbons attached to the carbon next to it. And the carbons on the inside of the molecule, the big chain, they're going to just have 2 hydrogens plus 2 carbons. So every carbon on the inside has 2, and every carbon on the outside has 3. So that's why we add the 2, because of the terminal ends. the front and the back just have 3. So if you're an alkane, it's 2 times the carbons plus 2. If you're an alkene, that means there's a double bond. That means you take away a hydrogen from each of the carbons making the bond, so you're actually subtracting 2. So the general formula for an alkene, the number of hydrogens is 2 times the carbons. For an alkyne, the number of hydrogens is 2 times the carbons minus 2. Be careful on the homework assignment whether it wants the formula or the molar mass. If you need the molar mass, first find the formula and then take the carbons times 12 and the hydrogen times 1 and add those together. So for formulas, a formula, we could have a Lewis structure. We actually draw it out where we connect all the dots. And so we'd have, like down here, we have butane. Butane we have 4 carbons, and you can see again, this has a formula C4H10. Why? Because the carbon on the ends, they each have 3 hydrogens attached to them. Carbons in the middle have 2, so it's 2 times 2 for the hydrogens plus an additional 2 on the end, so it's C4H10. This is the Lewis structure. It can be a lot to draw. There's some shortcuts I could talk about later, but this is basically what the Lewis structure looks like. Often, I'm going to use a formula that's a condensed formula instead, because this is a lot for me to type into Canvas. So I'm going to use a condensed formula for the most part. The condensed formula, the way it works is you say what's attached to the hydrogen, or sorry, attached to the carbon after it. So here, the first carbon has 3 hydrogens attached. The second carbon attached to it is 2 hydrogens. The third carbon has 2 hydrogens, and the fourth carbon has 3 hydrogens. So it basically takes this structure here and says, okay, this first carbon here, it has 1, 2, 3 hydrogens. So in the condensed formula, I'm going to put 3. This carbon here has 1, 2 hydrogens attached to it, so I'm going to put 2 hydrogens behind it. So in the condensed formula, we have the carbon, and then whatever comes after the carbon is what's attached to it. So here's just some general properties, and you can also see how these would be like condensed formulas. So for example, C10H22, we see that, okay, the first carbon has 3, second carbon has 2, 2, 2, 2, and so it just keeps saying what's on there. General idea here from this slide, you should be aware that the bigger the hydrocarbon, the bigger the boiling point. So some things like candle wax are like 17 carbon longs. They're like really big, long molecules. And so eventually you go from like being a gas for the small hydrocarbons, then you become a liquid in the mid-range, then when you get real big, you become a solid. So those are your standard hydrocarbons. A hydrocarbon is just carbons and hydrogens, and they're like, basically your vanilla flavor. You can change the flavor of the hydrocarbon and give it a new personality by adding a new molecule to it. We're going to call those things functional groups. A functional group is just adding something else to make it different. All right, one of those things is an alcohol. An alcohol is whenever you just take a hydrogen off of the hydrocarbon and replace it with an OH, hydroxyl. So that's all an alcohol is this, we've just basically have taken the vanilla hydrocarbon, pulled the hydrogen off from somewhere, and added an OH to it. That makes an alcohol. So ethane has just 2 carbons and 6 hydrogens. But ethanol, all that's happened is we've taken a hydrogen off and added an OH instead. So, and here we have some pictures like propane versus propanol. Propanol, the only difference is instead of having a hydrogen attached to this carbon here, we have an OH. So it's a new property. Propane behaves very differently than propanol. Very different. Propanol is a liquid, propane's a gas. They're both flammable. Propanol is a disinfectant. Propane is not a disinfectant. The general idea is when you change take one of the hydrogens off and replace it with a functional group, you change the personality, you change the flavor of the hydrocarbon. So in general, alcohols tend to be much more acidic than hydrocarbons because that hydrogen is now attached to an oxygen, which is a big bad bully. These things tend to be like, disinfectants. So another thing you can do is you can change it by just adding a halogen. So they're called alkylhalides. So you can basically take up a hydrogen, add a chlorine to it, or a fluorine or a bromine, and that's going to give it a new personality as well. So when you put those things on, though, we change the name so we know it's attached to a hydrocarbon. We just take out the ending. So instead of bromine, it becomes bromo. Instead of chlorine, it's chloro. Oh, I have a misspelling right there. Chloro should be a UO. Although you got to watch out on your homework assignment. Your autocorrect will want to make it fluorine or flour. So fluorine is FLUORO. We'll talk about that later. But halogens, again, they make it like more acidic as well. And both for halogens and alcohols, they make it have a higher boiling point too, because now the molecule is polar because you have a place that's negative. All right, I'm going to go ahead and stop here. I'm going to start talking about organic naming on the next video. So, God's peace.